Hello. In this lesson, we are going to be starting our unit where we derive a lot of the area formulas that we used last chapter. So last chapter we were just given the formulas and asked to use them. This chapter we're going to start to derive them. The first figure that we are going to be working with is called a parallelogram. A parallelogram is any quadrilateral that has two pairs of parallel sides. So the opposite sides are parallel to one another. Squares and rectangles are parallelograms because their opposite sides are parallel. One aspect about the parallelogram that is important for calculating its area is the height of the parallelogram, and the height of the parallelogram is defined to be the perpendicular distance between the bases. You can think about it as the elevation difference between the bases. It is the vertical height, is not the slant height. So for example, in this parallelogram on the left, the height of the parallelogram is the 4. It is not the 5. The 5 is the slant height. So the height for this parallelogram would be 4 feet. Likewise, the one over here would not be the 10, it would be the 8. It would be 8 inches. Where does the area of a parallelogram's formula come from? We're going to do a little visual or pictorial proof. I'm going to take a parallelogram and I'm going to cut it into more familiar pieces. I'm going to cut it into a rectangle and two smaller triangles, and I'm just going to move those pieces around. So here's the here's the rectangle, and here's the right triangle, and then I'm going to take this left triangle, I'm going to move it right next to the right triangle and below it, and voila, it makes a familiar shape. It makes a rectangle. The base of that rectangle and the height of that rectangle are the exact same as the parallelogram. So the height and the base have not changed. The area of this rectangle we know is base times height. That means that the area of the parallelogram also needs to be base times height because it's made up of the same shapes. So the area of a parallelogram is base times height. And now you see where it comes from. It comes from rearranging a rectangle into two triangles into a bigger rectangle. We're going to use those formulas now. So the first one asks us to find the area and the perimeter of the parallelogram shown. The area is the simpler of the two to find. So the area is just base times height, as we just saw. The base is 23, and the height is 24. 23 times 24 gives us 552. The units for area are always square, so this is square feet. The perimeter is all the way around the outside. I know from here to here is 23. I know this is 23, but now I need the slant distance. In order to get that, I need to use these dimensions that were given to me because it's a right triangle, and I need to find the hypotenuse, so I can use the Pythagorean theorem. 7 squared plus 24 squared equals c squared. That's going to be, what, 49 plus 24 squared is going to end up being 625, and that's actually a perfect square itself. When I take the square root of 625 is actually 25. So this is 25, and that means this is 25. So the entire perimeter will be 2 23s plus 2 25s. That'll be 46 plus 50. The perimeter is 96, and perimeter is one-dimensional, so it's just going to be feet because perimeter is a measure of distance, and distance is one-dimensional. So there's the first example, kind of the easier of the two that we're about to do. The second one is the same type of question, but we need to use a little bit of some old knowledge in order to get at some missing parts. I need to find the area and the perimeter of the following parallelogram, but I don't know the height. I'm missing this, so I need to pop this triangle out here and use a little bit of old knowledge. So I'm going to redraw that triangle right here. I know this is 30, I know this is 12, and I know this is the height. I'm going to have to use some trig because I don't know two of the sides. I cannot do the Pythagorean theorem. From this angle, I have the opposite. This is the hypotenuse, and this is the adjacent. Recall your trig ratios. Sine is opposite over hypotenuse. That was the so. Cosine is adjacent divided by hypotenuse. That was the ca. Tangent is opposite divided by adjacent. So ca toa from prior units. If I want to get the hypotenuse using if I want to get the height using the opposite, and I'm after the adjacent, opposite and adjacent uses the tangent ratio. So I want to calculate with a tangent of 30 will equal opposite, which is 12, divided by the adjacent, which is h. I multiply the h over here, and then I have h times the tangent of 30 equals 12. Then I divide by the tangent of 30, so 12 divided by the tangent of 30 will give me h. 12 divided by the tangent of 30 is 20.8. So I know that the height of my parallelogram is 20.8. So area is equal to base, which is 32, times height, which is 20.8. 20.8 times 32 equals 665.6 meters squared. Area is always square units. That's how I get the area. Now I want the perimeter, but I don't have this slant distance. I need the hypotenuse of that triangle. So again, I have to use trig. I have the opposite, and I'm going after the hypotenuse. That's the sine ratio, opposite and hypotenuse. So I know the sine ratio for my 30-degree angle would equal 12 divided by my hypotenuse. Let's call that c, like a squared, b squared, and c squared. So c. This is the exact same steps we did above. C will multiply, and then sine of 30 will divide down below. So C will equal 12 divided by the sine of 30, and 12 divided by the sine of 30 is going to equal 24. So this slant is 24, which means this is 24. So my total perimeter will be 2, what is that, 32s? 2 32s plus 2 24s. That's going to be 64 plus 48, and 64 plus 48, I believe, is 112. So the entire perimeter would be 112 meters. I'm going to ask you to try one. I would like you to find the area of the parallelogram shown. You're going to have to use trig as well in order to find the height. And I'm just asking about the area. So pause the video now. Unpause it once you've had a chance to try. Okay, welcome back. Let's talk about how you would do it. You need to use trig again. So here's your triangle that you need to draw. You've got a 45-degree angle. You're after the height, which is actually the opposite side, and you have the adjacent. So you're using the tangent ratio. Tangent of 45 will equal your height divided by 9. Just multiply 9 to the other side. 9 times the tangent of 45 actually equals 9, because the tangent of 45 is 1. So you know your height is actually equal to 9. You actually could have done this without trig. If this is 45 degrees and this is a right triangle, then this is actually 45 degrees. And if these two angles are the same, then these two sides have to be the same, because it's an isosceles triangle. So you could have done it actually without trig. Now you find the area, it's base times height. So 9 times 17 will make 153. So there's our first shape, parallelograms. Our second shape for this unit is triangles. The area of a triangle is 1/2 base times height. Where does the 1/2 come from? If you want to think about it for yourself, pause the video now because I'm about to inform you. It's a 1/2 because if you take any parallelogram, you can cut it diagonally and it'll make two triangles. And those triangles will have the same base and the same height, but they'll be half of the area of the original parallelogram. So the reason there's a 1/2 in front is because every single triangle could always be doubled and make a parallelogram that has twice of the area of that triangle. So the area of a triangle is always 1/2 of some parallelogram that has the same base and the same height. That's why its area is 1/2 base times height. Now we're going to use it. This application comes to us from like a gardening situation. A worker needs enough mulch to cover the triangular garden shown. Mulch is like the stuff that you put on top so things would grow, like soil. And enough paving stones to do the border. If one bag of mulch covers 12 square feet and one paving stone gives us 4 inches of border, how many bags of mulch and how many stones does he need to buy? So this is a perimeter and an area question. Let's try the perimeter first because I already have all three sides. The perimeter, I just add up 23 and 7 is 30 plus 15 more is 45. So the perimeter is 45 feet. How many stones would that take? Well, we need 45 feet of stones, and look, it says one stone does 4 inches. That means if I want 1 foot, I need 3 stones. So I can multiply by 3 stones over 1 foot, and feet will cancel. And 45 times 3 is going to make, what, 135, is that right? Yep, 135 stones. That's for the perimeter. Now we need to know how much mulch, and that's an area question. It's a triangle, so it's 1/2 its base. Its base here is 7. And its height is this 9. So 9 times 7 is 63 divided by 2. Half of it would be 31.5. So I need 31.5 square feet of mulch, but mulch comes in bags. So 31.5 square feet. It said that each bag does 12 square feet, I believe. Said it right there. Yep, 12 square feet for one bag. So I need to put square feet on bottom. So square feet will cancel with square feet. So 31.5 divided by 12 tells me I would need 2.6 bags. I can't get 2.6 bags, but I can get 3. So I need to buy 3 bags of mulch in order to cover the area. Second example. The height of a triangle is 8 more than its base. Its area is 105 square inches. What are its dimensions? Let's draw a little picture, actually. It says the height of a triangle is 8 more than its base. So it's a little taller than it is its base. So if this is its base, then its height here is 8 more than that. So from here to here is base plus 8. That's what the picture looks like. So what would its area be? Area is 1/2 base times height. Its area is 105. Its base is b, its height is b plus 8. So I need to multiply through, distribute. Gonna get 1/2 b squared plus half of 8 is 4, so 4b. Then I need to subtract, so subtracting, I get, because I need to equal to 0. 0 equals 1/2 b squared plus 4b minus 105. And now I have a quadratic. And because I have a quadratic, there's 2 things I could try. I could try factoring, but factoring is going to be tough, especially with this 1/2. So I'm going to use the quadratic formula. So let's try it. So you can either go to your calculator and use the quadratic formula program, or I'm just going to Google quadratic formula calculator, the very first option, and then I'm going to run it. A is 1/2, so 0.5. B is 4. C is negative 105. It's right there. And then I run it. And it tells me my value should be 11.03 and negative 19. It's not going to be the negative, so it's going to be the base is 11.03. So base is equal to 11.03. And then it said the height is 8 more than that, so if I add 8 more, it'd be 19.03. And that should be the dimensions of my triangle. Let's check it and see. If I multiply those two numbers, 11.03 times 19.03, and then take half of it, I'm going to get 105. So it works. Draw a picture. Picture is super helpful for solving geometry problems. And I'm going to ask you to try. So yours to try is this one. Here I'm telling you what the base, I'm asking you what the height is, and I'm telling you what the area of the entire triangle is. So pause the video now, unpause it when you want to come back and see how it worked. Okay, welcome back. Here's what you should have got. You should have got 21. 21 times 34 divided by 2 would be 357. How would you solve? Well, you'd say area of a triangle is 1/2 base times height. You plug in everything you know. 357 equals 1/2. The base is 34. Half of 34 is 17. If I divide 357 by 17, I should get 21. And that is it. Thank you very much. Have a good one.